All right. Matrix multiplication is nothing like matrix addition or subtraction or scalar multiplication. It is very weird. And it's very important that you remember this. So everything we've done so far is like, meh, whatever, yeah, we might have learned that at some point. It's easy. This, you have to remember how to do this and be able to show me how you did, okay? So let's read through these rules really fast. The number of columns in the first matrix must equal the number of rows in the second matrix. The size of the product will be rows of the first by columns of the second. If that doesn't make sense, let's write it out. So what's the dimensions of this? It's a 2 by 2. Okay, good. And what's the dimensions of this one here? Perfect. So these two numbers right here must match. Okay. And these two numbers right here are the answer. Well, they're not the answer. It's the dimensions of the answer. All right. That's what that first bullet point says. The entries of each row of the first matrix multiply with the corresponding entries in columns of the second. Products of the entries in each combination of rows and columns are then added to obtain each number in the answer, the product, whatever, right? So we're taking rows in our first matrix and multiplying them times columns in our second matrix. Now remember when we were back talking about adding matrices, we said the order we add them in doesn't matter because we're just adding corresponding entries, right? But now if we're very specifically talking about rows from our first matrix and columns from our second matrix, do you think order now matters?
Yeah.
Yes, and in fact, if you are able to multiply A and B together and then multiply B times A together, you will likely get different answers for each one, if you can multiply them. In this case, if we were to switch them, we can't even multiply them in the opposite order because that number would come first and that one second, and those two middle numbers won't match. That makes sense. I can write that out if you're not sure. So BA, matrix B would be a 2 by 3, and matrix A would be a 2 by 2, and these two numbers don't match. And so multiplying in that order would be undefined. You would not be able to do it because there's no definition for that type of multiplication. We haven't actually multiplied them yet. We're only setting this up so far. Okay, are we ready to multiply?
Yeah.
Are you afraid?
Somewhat, yeah.
Don't be afraid. You'll get this. This is one of those things where practice makes it come more easily. So this is where I would say, they're a little time-consuming and annoying, but honestly, practicing, just, that muscle memory, getting it in your head really helps. Okay, so rows times columns. So I'm going to do 1 times 3 plus 2 times negative 1. So 1 times 3, so I'm multiplying this times that, and that times that.
And then you have to
Yeah. So we have a 3 and a negative 2, which gives us a 1. So I'm going to start making my answer over here. How big did we say our answer is going to be?
It's going to be 2 by 3.
So 2 rows by 3 columns. So I'm just setting up my brackets so that it's big enough. And this work right here resulted in a 1, and that's going to go in that top corner right there. If you want, you could even write it out as a ginormous matrix with all your work shown, and then your answer. I don't know if that's even going to be enough space. I don't always show my work on these. Sometimes I just do them in my head. But when you're practicing, that's fine. On the test, show the work somehow, like I'm doing. All right, let's do now the first row. Oh, I meant to change the color. It didn't take for some reason.
And you have to do the second.
The second column. Yeah.
Right, so you're doing the top row from the first one to each column, and then you're going to do the same thing with the bottom row of each column, right?
Yes. Yeah, so you're gonna have 1 times 0 plus 2 times 2, correct? So that would be 0 plus 4, which gives us a 4 in that spot. So when I did this first problem, I actually wrote out all the work. Just now I was lazy, did it in my head, wrote it real quick. So, all right. Yeah, you guys can just go for this. See if you come up with the same thing I do. Or keep watching if you're not sure. I'm trying to color code each step. So 1 times 5 and 2 times 4. So that will be 5 and 8 added together, which is 13. If you guys are working on your own, you'll definitely help me catch my mistakes if there are any. So -2 and 3 plus 3 and -3. How did that go? So -6. Wait, am I multiplying the wrong thing? What's a 1? I got distracted because my pen changed color all of a sudden. So -6 and -3. Did you say -9? I was trying to make that one purple and then my work changed colors on me. Am I going slow enough? Yeah, that's okay. Then I'm going to do second row, second column. So that's going to be -2 times 0 plus 3 times 2. So 0 plus 6, which is 6. And I don't know what color to choose. Why is it not like a nice bright pink? I don't know, I'll just do bright green maybe. Or aqua. That will work. So then we'll have, this makes sense. Cool. So -2 times 5 plus 3 times 4, so -10 plus 12. So 2.
Yeah.
You guys come up with the same answer I did. So that is A times B. So what we just did. And we couldn't multiply B times A because it wasn't defined. And even if we could have multiplied B times A, we probably would have gotten a different answer. So what we're about to learn in section 6.5, just remember that the order to make it work is going to be essential. All right, we move on. Should I save that in one video, perhaps?
Yeah.
Actually, you know what? I'm just going to go ahead and talk through what we actually already talked about, but I didn't video it. I'm just going to go on to the next page really fast. Hope you guys are okay with that. So the identity matrix is a square matrix with ones along the diagonal from top left to bottom right. All other entries are 0. I sub k is a k by k identity matrix. So I sub 2 equals 1, 0, 0, 1. I sub 3 would equal 1, 0, 0, 0, 1, 0, 0, 0, 1. The 3 indicates it's a 3 by 3. The 2 is a 2 by 2. We have the diagonal of 1s. We have 0s everywhere else, right? So we have this property we're going to talk about. We're going to change colors so we can see a little easier. That awkward doesn't show up very well. So for our property, what we're showing is that the identity matrix times A is equal to A times the identity matrix, which is equal to A. So remember how earlier we talked about the identity, the additive? Oh, that was the additive inverse, wasn't it? I'm getting off a little bit. But if you add like a 0 matrix to a matrix, you'll get the same matrix back again. That's because that's the additive identity. This is the multiplicative identity. We don't even care about the additive identity. All we care about is this multiplicative identity. So anyway, just for fun, let's go ahead and multiply 1, 0, 0, 1 times, can we 0, negative 1, negative 10, 3, 5. So even though the matrix I'm multiplying by is 2 by 3, I need these two numbers to match. So what size matrix would I use to multiply this together in order for it to work? So to show the property is true, I need to multiply matrix A by an identity. So if I multiply the identity first, then I need it to be a 2 by 2 so that those numbers are both 2s. Does that make sense? Okay, so let's do that really fast. So quickly, this, oh, I did it backwards. This times this. So what happens if I multiply 1 times 2 and 0 times 10? 2, because the 0 cancels out the 10. Then I move that over here, 1 times 0 and 0 times 3. 0, right? 1 times negative 1 and 0 times 5. Now we move on to the next row. 0 times 1, or 0 times 2 and 1 times negative 10. So the 2 turns into a 0, and we're left with negative 10. 0 times 0 and 1 times 3. 0 times negative 1 and 1 times 5. So following the rule we just learned for multiplying the identity should give us the exact same matrix again. How would we do it the other way around? So I just did I times A, but what if we wanted to do A times I? Can we multiply by a 2 by 2? Yeah, so it would work the same. I'm not going to take the time to go through it other than to just write it down. But if you were to take this 2 by 3 and multiply that by a 3 by 3, you should get the, so it's a 3 by 3, so that those two numbers match, right? You should get the same exact answer back. So it doesn't matter which order you do it in, but it does matter that you make sure you use the identity that matches the dimensions so that you can do it. If you're doing it in that order, you have to use the 3 by 3. If you're doing it in that order, you have to use the 2 by 2. And either way, you're going to prove the property. That was the whole point of this, is that we're proving this property here. Okay, I'm going to go ahead and save that video at that point.